Welcome to my Odyssey. Welcome to Lancaster Hi-Fi. I'm Stephen Lancaster, and I'm inviting you into my trials and tribulations with trying to rehab, restore, fix, pardon my recovering voice, of this Kenwood KA-9100. A pretty awesome integrated amp. But it seems that this one has some problems. And this one has some problems. I have done a few things with it. It had a problem with the phono preamp, and I think I've gotten past those. There were some problems with the power supply. I seem to address those. I've replaced the filter caps. I've replaced quite a few components, not wholesale replacing components, but replacing lots of components on the road to trying to fix various problems. And the last problem that I'm up against is an intermittency of one of the output stages. And what I am struggling with is, what's the source of that intermittency? Is it something to do with the driver board, or is it something to do with the output module? Now, this amplifier has a Trio Kenwood pure complementary power amplifier TA-100WA output integrated circuit. These are irreplaceable. Well, they can be replaced, but you can find a bunch of Chinese knockoffs, which may or may not work and may or may not function as the original. You know, if you're exceptionally lucky, you could find a new old stock module for sale somewhere. But I've not been able to find one of those. If you're just really lucky, you can find a module taken from a working unit that's been parted out. Or there's an outfit called Pyramid Audio or something like that that makes replacement, discretized replacement modules. You can even, take them apart and sort of rebuild them on the inside within the same case. But that's akin to a replacement discretized version. Now, any of these options is relatively costly. Even the knockoffs from China are going to, at a minimum, cost you like $40 each. The Pyramid replacements are, I forget, something like $85 each. And if you could find a NOS version of one of these, boy, I don't know. I've done a number of tests which seem to indicate that the problem should be with the driver board and not with the output module. But everything that I do to that driver board seems to have no effect on, or limited effect on, the problem. And the problem is that the outputs which are supposed to sit at 0 volts DC, which is not ground per se, it's definitely not ground, but it's the signal, center, 0 volts. And that will occasionally just go plunk down to like the negative supply of around minus 57 volts. And where that happens, there's a current source transistor that seems to saturate. All of a sudden it just draws crazy current, or maybe it doesn't draw any more current, but just saturates. And voltage that it should have, where the collector is sitting up at about minus 1 volt, suddenly drops to within a couple of tenths of a volt of the emitter. That is, the transistor saturates. So I've tried several, at least a couple of different replacements of that particular transistor in an attempt to fix this problem. I've changed the diodes that set the bias on the base of that transistor. I've replaced some of the resistors in that bit of circuit, you know, just kind of searching, reaching for something other than having to replace the output module. But I don't want to replace the output module if that's not the problem, right? I want to be damn sure that it's the output module that's failing if I'm going to have to replace it, because it's irreplaceable. Okay, so my final experiment. I've got a good right channel and a bad left channel. So last night I went through the laborious process of removing the output modules from both channels and switching them. So now I've got the one that, and I labeled them before I switched them. So now I've got the one labeled L over in the right channel, the one labeled R here in the left channel. And now we turn it on and we monitor. I've got this, the scope traces are DC coupled here, and we're looking at very large time steps of 100 milliseconds. Probably can't see it, but it's sort of tracing across here over and over at about a second. So what we want to do is turn this on, and these should, if it's working right, sit where they are at 0. We'll see a bit of transient. Well, the protection relay clicks when the transients are close enough to 0. And then it should stay there. Now, here's the experiment. We should still see a failure because I haven't changed anything from the last time that it failed except to switch these output modules. So here's what the couple of things that we should see. Either the problem lies with the driver board and therefore the failure stays in the left channel, or the problem is with the output module and the failure switches to the right channel. Now I've done this experiment, I've tried this once and not been able to get the failure mode, but maybe I just didn't give it long enough. So we're going to try again. This is one of those things, you know, when you're trying to fix electronics and you've got a failure that is, you know, it's probably thermally related. It's probably at least somewhat contingent on heat. It doesn't mean it's not a failure, but it means it's probably encouraged by higher temperatures. So one thing I could do to encourage the experiment is sort of close up the chassis here. I've got, right now though, the bottom is off, the top is off. So there's more air circulation than there would be normally. But we should still be able to get that failure mode. But here's the thing. Here's the thing. What if this has fixed it? I've already noticed that right and left channels are behaving more similarly than they were previously. Which is not to say they're both behaving better, but at least they're behaving similarly in the transient. Which seems a bit odd. So what if I've somehow fixed it? By doing nothing. Well, no, of course I did something. I did a pretty major thing. I took the friggin' things apart, right? Put them back together, but reversed the output modules. What if somehow that's fixed it? That's messed up. That would be awesome, but just doesn't seem right. It doesn't seem like it should be a thing. All right, well, anyway. Here goes. You see the transient. Might have heard the click there of the relay. And now we wait. Yep, doing it again. So this is the power amplifier circuit. We've got the Darlington complementary pair IC here. There's also another IC with this pair of JFETs at the input. And both of them have current sources below them. This one, this current source goes to pin 7 on the IC on the output. And this current source goes to the bottom of this differential pair here. So here's the output over here. When that voltage goes negative, it's supposed to be at 0, but when it goes negative to minus 50 something, this also goes negative, which indicates that the current through this transistor is saturating. Normally that would happen if I jacked up the voltage here on the base to tell it to draw a whole lot more current and drove it till saturation. And in saturation, this collector would drop within a couple of tenths of a volt of the emitter here. But this should be a stable voltage. It's simply sitting on top of a couple of diodes connected to the negative supply. On the other end, it's got a 27K resistor to ground. So there's really nothing to move this voltage around. Nevertheless, I have monitored that base during this particular malfunction. And during the particular malfunction, okay, yes, voltage here drops very negative, voltage here drops very negative, where it should be minus 1.15 volts, it drops to near minus 56. This voltage goes up maybe 10 volts. And I can't tell you exactly how much because I've only monitored it from across the room here. Because I'm not going to sit there all day watching that damn thing in that chair, which is not super uncomfortable, but I'd much rather sit here on my couch and listen to music. I have replaced this transistor with a couple of different things. Maybe 3 different things. And the transistor in there now is pretty beefy. It's a TO-226 type package. It doesn't have as much gain as the original 2SC1885. And I think the original is an R, 1885R. Doesn't have as much gain as that one, but it can handle a whole lot more current, a whole lot more power dissipation. So what the hell's happening? I don't know. I have not monitored what exactly is going on with this transistor. But I can only surmise that if the voltage, when this goes negative, this is going positive, and not by positive, I don't mean it's going to an actual positive voltage. It's rather than minus 55 volts, it's going up to like minus 45 volts. And that would be enough to also drive the hell out of this transistor and probably take this voltage quite negative as well, where it should be at 0.75 volts. Being a nice current source for here, nice constant voltage there, that'll instead get drawn negative. Why? I don't know. Now, this idea of a transistor somehow getting made to saturate and thereby also jacking the voltage on the base, I don't get it. I mean, that's not how transistors work as far as I understand it, but I guess I don't understand it because there's nothing else to jack this around. Right? The only thing that could be moving this is if the transistors are doing something screwy somewhere else. Because again, it's just that's ground, that's a 27K resistor, 2 diodes. I've replaced those diodes. I've replaced that resistor. I've replaced that resistor. The only one I haven't replaced is this one because I didn't have an 81 ohm resistor to replace it with. But it's in spec. They were all in spec. I just went ahead and replaced them anyway, the ones that I had. So maybe I need to replace this transistor. Now, I think I probably already have, but maybe I haven't. I'm not sure. But if I have replaced it, maybe I need to put something beefier in there. But it raises the question is, well, if things are going so haywire here, why aren't they going haywire on the other board as well? I don't know. But at least my experiment has revealed that the output integrated circuit isn't the problem, which is a huge relief, because replacing those is a total pain. I mean, not physically, I switched them around, but man, actually trying to find a new one, pretty near impossible. Finding a replacement is okay, you know, you can do it, but they're going to be $85 each for, you know, a circuit that's not the original. Is it as good as the original? Maybe. Maybe it's better. I don't know, but it's not the original. Now, there's another issue that I'm having, and that was a buzz at the output. One thing that we can look at, I didn't show before, is just what we see at when the volume's all the way down, input's 0. If I want to see the noise that I had before, which was at about 120 hertz, because it's power supply noise, of course. And that's what we got. It's pretty ugly. We've got a few millivolts of noise, and it's a buzzy noise. It's not nice. I mean, that's not, you know, it's not awful, but it's audible. At no volume, it's audible. And I don't know what that buzz is from, but kind of figure it's power supply. And which power supply is the problem, or is it all of them? Now, one potential place to look would be over here. So here we've got 57 volts. Then it drops through this 3.3K. And then there's a 24 volt Zener here. And so this is 24 volts. And we've got just this 100 microfarad capacitor here to provide some additional filtering. You know, it's a low pass filter, the 3.3K and the capacitor there. A better way to design that to make it super quiet would be to put this on the base of a transistor for a capacitance multiplier. So you'd have this and this on the base of a transistor, where the collector would be up here, either at 57 volts, which you could do, 57, you know, if you had a beefy enough transistor to pass that amount of voltage, drop that amount of voltage, and then have the emitter be that 24 volt supply. If you did that with the same 24 volt Zener, then the emitter would be 0.6 or so volts below that voltage at the base. So you might therefore jack this up to a 25 volt Zener to compensate. That would make it super quiet. Another thing to do is you can put bypass capacitor or two to complement this 100 microfarad one. And typically when you do bypass capacitors on a power supply like this, you'd go down by a couple orders of magnitude. So you could bypass it with a 1 microfarad capacitor and say a 0.01 microfarad capacitor. Or maybe something in between those, a 0.1 microfarad capacitor as a compromise if you just wanted to try one. It might be an interesting experiment if and when I take this board out again to maybe replace these transistors again. Man, obviously I need to do something. I had this thing going for hours. You know, it has malfunctioned a couple of times within a few seconds of each other. I missed getting it on video. But clearly that's unacceptable. I mean, if it were just bugging out, if it were just cutting out for, you know, a fraction of a second, you know, every several hours, that wouldn't be the end of the world. But I know that it's also going to be sending a big pop to the speakers. And that's not cool. You know, the relay doesn't cut out quickly enough to avoid sending a big pop to the speakers when it does that voltage drop thing. Man. This thing's killing me. Not literally. I may sound like death, but... Let me just wrap this up. I'm not going to wait till I get this problem solved to publish this video, because that's not quite the point of the video. The point of the video is simply to show you a snippet of problem solving in vintage audio repair. You know, in this case, I've got a very expensive, hard to find part that might be the failure point. I need to rule it out. And at this point, you know, in the real world, there's just a couple of possibilities of part changes that can fix this problem. You know, it comes down to a different resistor for the current source for the output IC and maybe a different transistor for the current source for the input IC. And it's really only those two things that can have an effect. At least I think that's right. It's just wild, though, that I ran that amplifier for all day yesterday. I mean, just hours and hours and hours. And the malfunction occurred like 3 times. You know, let's say the total time of malfunction was probably about 1 second. Maybe a little bit more, maybe, probably not even 2 seconds. Wasn't even able to catch it on video, even though I shot lots and lots of footage. Just, you know, kept the camera trained on that, because I also wanted to keep the camera trained on it in case my eye wandered or I didn't hear it when it happened. That's sometimes what's involved in restoring an old piece of vintage gear. This one's been particularly difficult, but I don't know, has it been particularly difficult or just... These output stages when an output stage malfunctions, there's just a lot of current and voltage involved, and parts that seem like they ought to be fine can fry like that. And parts that seem like they ought to be fine are fine for most of the time until they're not. It's kind of maddening. You know, I guess I'll say at least I've narrowed it down to 1 or 2 components in there that could solve the problem. And I'm just going to need to go back to the drawing board, look for suggestions regarding replacement transistors for those 2 components. Anyway, I hope you might have found this video instructive, useful, informative, what have you. If you have, please give it a like. Subscribe to the channel, please. Trying to get that 10,000, creeping towards it. Be awesome to reach it. But mostly, I hope you enjoyed the video, and I hope you'll tune in again. And if so, I'll talk to you later. And I just can't get